Hey, my name is Felix Agene.
I'm Jack Moore. We're Team 23, and this is our final project.
For our final project, we did a recharge station with battery and a data collection. For it, we made a battery and added it onto the drone to make the drone more realistic in a real life scenario. And we added multiple recharge stations so that the drone has to route to the nearest station and implement a shortest paths algorithm. For the data collection station, we added simple data like battery usage, distance traveled, and total entities on the map.
So for this project, we used several design patterns. For the recharge station, we extended the already in place composite factory pattern. So we created a recharge station factory that creates entities of type recharge station. We also extended the decorator class, creating a drone battery decorator. And this is the actual battery itself. It's simply a decorator tacked onto the drone object. And then we also utilized the singleton pattern. So for the data collection, there's only one instance of the data collection class that several different entities have access to, and it tracks data all throughout the simulation until it's stopped. So this is our actual simulation. As you can see, it's a map of the U of M campus. You can see several recharge stations around the map. There's three of them. Currently, there's a helicopter flying overhead. There's just been a message up in the left. So we have a notification system that will send out notifications from the entities. So right now our data collection is actually tracking the distance this helicopter is moving. And then within the UI, there's several buttons. So you can add humans to the simulation, and the data collection will also track their distances. As you can see, they're running around the map here. And then you can also add drones to the simulation. And the drones are like the main part of the simulation. There's a lot you can do with them. And so you can schedule trips with them, and they will deliver packages.
Okay. As you can see, once we start to schedule trips like pack, we can see that the battery of the drone will immediately start to run, and the drone will go towards the package until its battery percentage reaches below a certain threshold, which for our case is around 20%. Once it hits that 20%, it will reroute, as we see in our notifications, to the nearest recharge station, recharge, and then either go back to the original trip that it was on, or it will just stay at the recharge station until a trip has been scheduled.
So once you stop the simulation, immediately you will have this table outputted in the terminal. And this table is the result of our data collector class. So as you can see, we have a bunch of entities and data tracked with them. So every drone is going to have its distance tracked, and then also how much battery is used over the life of the simulation, as well as how many packages it delivers. For the humans and the helicopters, there's not much interesting data, so we just have the distance traveled. And then for each package, there's going to be a time amount, so how long it took from the initialization of the package until its delivery. And we thought this was very interesting, realistic for like a delivery service to know how long deliveries are taking. Additionally, all of this data will be written to a CSV file, as you can see at the top of the screen here, and you can use it from there as well as the table. All right.
Now, for a bit of our source code, we have here our drone battery decorator, which we use to extend the functionality of the drone while adding a drone object into a battery object into our drone, sorry, and allowing it to now have the functionality of battery usage and battery life, and also be a drone. Is we see in our .h file, we are extending from that same drone and calling our drone constructor method and battery constructor method, while also adding a few extra methods like get battery life, recharge. Those are just simple helper function, but for the main one, our update function, we had to change a bit of code as we needed to make sure that if the drone already had a package and was routing towards that package, but needed to be recharged, it needs to still go and take that same destination method or pathfinding method, and it needs to use that same method to continue after it's done charging, obviously. And so in our update function, we had a little bit of code like if it's if the battery life is less than 25% and it's not already routing to a recharge station, then we need to start the logic for routing towards that recharge station. And then we need to essentially change our final destination pathfinding method to the one to go towards our recharge station. And then once we're done, we need to change back our final destination to a new final destination path, which would be from the recharge station towards either the final destination of the package or where the package is, depending on whether the drone has already picked up the package or not.
All right, so this is a little bit of our source code for our data collector class. So as you can see here at the bottom, our data is all collected in a bunch of maps. So they take in the object type and then whatever we're tracking. So packages delivered or battery or whatever it is. The files, excuse me, the methods here aren't that interesting. Most of them are simply writing to these maps. Um, we also have like write to CSV is called in the destructor of this class. That's when it's outputted to a CSV file. Print table, same thing. And then we also have a private constructor to adhere to the singleton principle. And the only way this class is accessed is through the get instance method. And there's a single instance because it's a singleton.